On a crisp December morning in 1903, a small, fragile machine lifted off the sand dunes of Kitty Hawk, North Carolina. For only 12 seconds, it hovered above the earth, but in that brief moment, the impossible became reality. Humans had conquered the air. This was not a spectacle for entertainment, it was the opening chapter of a technological revolution that would soon transform warfare, industry, and human imagination. At the dawn of the 20th century, the world was on the cusp of change. Trains, automobiles, and telegraphs had already begun to reshape society, but the sky remained untamed. Aviation was largely considered a fantastical dream, something achievable only in theory. Many inventors and engineers experimented with gliders, kites, and even rudimentary engines, but reliable controlled flight remained elusive. It was into this environment that two brothers from Dayton, Ohio, Orville and Wilbur Wright, entered with a vision that combined meticulous observation, mechanical skill, and relentless determination. The Wright brothers were not formally trained engineers. Wilbur had dropped out of high school, and Orville had pursued only informal studies, but both were deeply fascinated by mechanics and the natural world. Inspired by the flight of birds and earlier experiments by European pioneers, they believed that controlled, powered flight was achievable if one could understand the principles of balance, lift, and propulsion. Their approach was methodical. They began with kites and gliders, conducting thousands of tests and refining control surfaces to ensure stability in the air. Unlike many contemporaries, they focused not only on generating lift but also on controlling pitch, roll, and yaw, the three critical axes of flight. By 1903, their experiments had culminated in a machine that was ready for powered flight. The Wright Flyer, constructed from spruce and covered in muslin, was equipped with a small gasoline engine and twin propellers. Its design incorporated the brothers' innovative control system, wing warping, which allowed the pilot to maintain balance and direction during flight. On December 17, 1903, Orville Wright piloted the Flyer for the first successful flight, covering 120 feet in 12 seconds. Wilbur followed with a second flight that stretched 175 feet. 4 flights in total that day proved not only that controlled flight was possible but also that the era of heavier-than-air machines had truly begun. News of the flights spread slowly at first. The Wright brothers were cautious, wary of exaggeration and eager to perfect their technology before seeking public or commercial attention. Yet, their accomplishment did not remain hidden. By 1908, they were ready to demonstrate the Flyer to larger audiences, including military representatives. The world had changed in just 5 years. Airplanes were no longer theoretical exercises but practical machines capable of carrying humans, albeit for short distances, above the ground. The U.S. military, particularly the Army Signal Corps, had begun to take notice. At that time, the Signal Corps was responsible for communication and technology experimentation within the Army, and its officers were keen to explore whether airplanes could serve a strategic purpose. Messages could be relayed, enemy movements observed, and reconnaissance conducted far beyond the capabilities of ground scouts. Yet skepticism was high. Many officers considered flight too fragile, too experimental, and too dangerous to be of practical military use. The Wright brothers were invited to demonstrate their aircraft at Fort Myer, Virginia, in 1908. This was no simple exhibition. The Army sought a machine that could reliably take off, fly controlled circuits, and land safely, all essential for operational deployment. Orville Wright piloted the Flyer under the scrutinizing eyes of Army officials and engineers. The plane performed flawlessly, demonstrating precise control, stability, and the ability to carry a human observer. The military observers were impressed, though not entirely uncritical. Modifications were requested, including improvements to safety, endurance, and operational practicality. Despite these challenges, the Wright's aircraft had proven one essential truth: heavier-than-air machines could be controlled, repeated, and eventually adapted for strategic use. The U.S. Army recognized the potential. After further testing and adjustments, the Army purchased the aircraft in 1909, officially designating it Signal Corps Airplane No. 1. This acquisition marked a watershed moment in military history, the first time the U.S. military officially integrated an airplane into its ranks. What began as an experiment on the sandy dunes of Kitty Hawk had now become a formal instrument of national defense. The significance of this purchase went far beyond a single airplane. Signal Corps Airplane No. 1 established the foundation for military aviation in the United States. It inspired the creation of dedicated training programs, operational protocols, and eventually, organizational structures that would lead to the aviation section of the Signal Corps in 1914. More importantly, it demonstrated that flight could serve as a tool of reconnaissance, observation, and potentially combat, ideas that would be fully realized in the decades to come. The Wright brothers' innovation also sparked a cultural shift. Newspapers, scientific journals, and public audiences celebrated their achievement, portraying the flyer as a triumph of ingenuity and courage. The American public began to see airplanes not merely as curiosities but as symbols of progress, national pride, and technological supremacy. Military officers and policymakers, too, began to embrace the idea that air power could one day rival traditional branches of the armed forces in importance. Challenges remained, of course. Early aircraft were fragile, engines unreliable, and navigation primitive. Pilots faced immense risks, and training programs were rudimentary. Yet the vision set by the Wright brothers, combined with the Army's willingness to invest in experimentation, laid the groundwork for future successes. Every flight, every test, and every modification contributed to a growing body of knowledge that would eventually enable U.S. forces to dominate the skies in World War I, World War II, and beyond. By the end of the first decade of the 20th century, it was clear that aviation had moved from a dream to a reality. The Wright Flyer had done more than fly, it had transformed the military, inspired innovation, and altered the course of history. From the quiet sands of Kitty Hawk to the structured testing fields of Fort Myer, the first chapter of U.S. military aviation had been written, and it was a story of vision, courage, and the relentless pursuit of flight. In essence, Chapter 1 of American military aviation is a tale of ingenuity meeting opportunity. The Wright brothers' Flyer was the seed from which an entire branch of the armed forces would grow. It showed that with careful experimentation, daring, and unwavering commitment, humanity could transcend gravity itself. For the U.S. military, it signaled the beginning of a new era, one where the sky was not the limit but the battlefield. Signal Corps Airplane No. 1, America's first military aircraft. The story of Signal Corps Airplane No. 1 begins with the Wright brothers' efforts to transition their invention from a demonstration of ingenuity into a practical tool for military use. While the Kitty Hawk flights of 1903 and the Fort Myer demonstrations in 1908 proved that controlled flight was achievable, the U.S. Army required machines that could withstand repeated use, carry passengers safely, and perform reconnaissance reliably. Meeting these standards was no small task. The U.S. Army Signal Corps, responsible for military communication and technological experimentation, initiated a formal evaluation of the Wright Flyer in 1908. Orville Wright conducted a series of controlled flights at Fort Myer, Virginia, under the watchful eyes of Army officials and engineers. Each maneuver, takeoff, climb, turn, and landing was closely monitored and recorded. Officers analyzed engine performance, control responsiveness, and the plane's ability to carry an observer along with the pilot. During testing, a mechanical failure led to a crash, injuring Orville. The incident underscored both the fragility of early aircraft and the necessity for rigorous pilot training, mechanical reliability, and operational safety protocols. Despite the accident, the Army recognized the potential of the aircraft for reconnaissance and observation, ultimately deciding to purchase it. In August 1909, the U.S. Army formally acquired the plane, naming it Signal Corps Airplane No. 1. This purchase represented the first official integration of a powered, heavier-than-air machine into the U.S. military. The contract also required the Wright brothers to provide detailed instruction manuals, train personnel, and ensure that the aircraft could operate under military conditions, effectively formalizing the Army's involvement in aviation. The plane itself was modest in modern terms, a 12-horsepower engine, a wingspan of just over 40 feet, and an exposed framework that required the pilot to balance skillfully while controlling pitch, roll, and yaw. Despite its simplicity, it represented a significant step forward. For the first time, the Army had a tool capable of observing enemy positions from the air, transmitting intelligence more efficiently than traditional methods, and experimenting with tactical maneuvers beyond the limitations of ground reconnaissance. Once in service, the aircraft became central to training and reconnaissance operations. Pilots learned to manage the delicate balance between engine power, wind resistance, and control surfaces. Every flight was meticulously logged, documenting performance, mechanical issues, and environmental factors such as wind and temperature. These logs formed the foundation of early military aviation doctrine, informing subsequent aircraft design, pilot training, and operational procedures. Signal Corps Airplane No. 1 also had symbolic significance. Its introduction at Army installations and public demonstrations drew attention to aviation's potential as a military asset. Newspapers and journals highlighted the bravery of the pilots and the technological innovation of the aircraft, framing it as both a national achievement and a strategic necessity. The plane became a tangible representation of America's commitment to innovation in defense and preparedness for modern warfare. Institutionally, the acquisition of the Signal Corps Airplane No. 1 catalyzed the formation of dedicated aviation roles within the Army. By 1914, the aviation section of the Signal Corps had been established, formalizing the training of pilots, the development of operational procedures, and experimentation with new aircraft designs. Lessons learned from the Signal Corps Airplane No. 1 including engine reliability, mechanical maintenance, and pilot safety were directly applied to the creation of manuals, standards, and protocols that guided early military aviation. The operational implications of the aircraft were significant. Even with its limited range and payload, the plane demonstrated the potential of aerial reconnaissance to influence battlefield decisions. Military planners realized that observing enemy troop movements from above offered an unparalleled tactical advantage. These lessons laid the groundwork for the development of artillery spotting, mapping, and intelligence gathering techniques that became standard practice in later conflicts. Signal Corps Airplane No. 1 also influenced the trajectory of aircraft design and technology. Engineers learned from the plane's performance limitations and strengths, gradually improving engine power, structural durability, and aerodynamic efficiency. These iterative improvements paved the way for the more advanced fighters and bombers that would dominate the skies during World War I and World War II. The collaboration between the Wright brothers and the Army established a precedent for civil-military partnerships in technological innovation. By providing training, technical support, and ongoing refinements, the Wrights helped create a culture of experimentation and adaptation within the military. This culture became essential as aviation rapidly advanced, ensuring that the United States maintained a strategic advantage in air power development throughout the 20th century. By the conclusion of its service, Signal Corps Airplane No. 1 had become more than a functional aircraft, it was a symbol of innovation, determination, and national ambition. It demonstrated that even early, fragile machines could profoundly influence military strategy, shaping how the United States approached reconnaissance, training, and tactical planning. The aircraft's lessons resonated through subsequent decades, ultimately contributing to the establishment of the U.S. Air Force in 1947. In summary, Signal Corps Airplane No. 1 marked the first serious integration of aviation into U.S. military operations. It combined the Wright brothers' ingenuity with the Army's foresight, producing an aircraft that was operationally significant, symbolically important, and historically transformative. The plane's practical achievements from reconnaissance flights to pilot training and its role in shaping military doctrine ensured that it would hold a permanent place in the history of American air power. In the evolution of military aviation, Signal Corps Airplane No. 1 stands as the spark that ignited a century-long journey of technological innovation and strategic mastery of the skies. The period following the purchase of the Signal Corps Airplane No. 1 saw a transformation in American military thought. The Wright brothers' invention had proven that flight was possible and valuable, but integrating it into the armed forces required not only technological innovation but also a cultural shift. The Army had to learn how to recruit, train, and deploy pilots, while simultaneously developing doctrines and strategies for aerial operations. By 1914, the aviation section of the Signal Corps had been formally established. This marked the beginning of a structured approach to military aviation in the United States. The section was tasked with managing aircraft acquisitions, pilot training, maintenance protocols, and flight testing. Early pilots were trained in a mixture of hands-on experience and technical knowledge, learning how to navigate, operate primitive instrumentation, and troubleshoot mechanical failures mid-flight. Flight logs from this era show repeated attempts to refine landing techniques, engine management, and weight distribution, all critical for the safety and effectiveness of early missions. As European tensions escalated into World War I in 1914, the United States initially remained neutral. However, military planners observed the war from afar, studying how aircraft were being used for reconnaissance, artillery spotting, and tactical support. European powers like Germany, Britain, and France had already recognized the strategic advantages of aerial observation, employing aircraft to gather intelligence, monitor troop movements, and coordinate artillery fire. These developments highlighted the urgent need for America to expand and modernize its own aviation capabilities. By 1916, the United States began to accelerate its military aviation program. Congress allocated funds for additional aircraft, flight schools, and maintenance facilities. Engineers experimented with more powerful engines, improved propeller designs, and stronger airframes capable of carrying heavier payloads. The focus remained on reconnaissance, as early military doctrine emphasized gathering intelligence over direct combat. However, lessons from the European front gradually influenced American thinking, paving the way for future combat-oriented aircraft. The first American pilots deployed to Europe in 1917 encountered a harsh reality. European airfields were often rudimentary, maintenance facilities were limited, and early aircraft were fragile compared to the rapidly evolving designs on the front lines. Despite these challenges, American aviators demonstrated remarkable adaptability. They learned to operate in difficult weather conditions, navigate unfamiliar terrain, and conduct coordinated missions with Allied forces. Their experiences contributed to the development of standardized procedures for aerial combat, navigation, and communication that would endure long after the war ended. A significant development during this period was the emergence of the fighter pilot as a new kind of military hero. Pilots such as Eddie Rickenbacker and others became celebrated figures for their bravery and skill in the air. Dogfights, reconnaissance missions, and the risk of mechanical failure combined to create high-stakes situations that demanded quick thinking and exceptional courage. These individuals not only demonstrated personal heroism but also helped shape public perception of aviation as a critical component of modern warfare. American military aviation also expanded its infrastructure during this period. Airfields were constructed near training facilities, and specialized workshops were established to repair and modify aircraft. This logistical development was essential. Early aircraft were prone to mechanical failure, and maintaining operational readiness required skilled mechanics, engineers, and supply chains for spare parts. The emphasis on infrastructure laid the groundwork for the post-war expansion of the U.S. Air Service and later the Air Force. Technologically, World War I accelerated innovation. Aircraft evolved from fragile reconnaissance machines into more robust platforms capable of limited combat operations. Engineers introduced synchronization gears allowing machine guns to fire through propellers, strengthened fuselages, and experimented with aerodynamic shapes to improve speed and maneuverability. While the United States entered the war later than European nations, its pilots and engineers quickly adapted, leveraging lessons learned from the Signal Corps Airplane No. 1 and early domestic experimentation. The war also highlighted the need for coordination between ground and air forces. Observers in aircraft relayed critical information about enemy movements, which directly influenced artillery accuracy and troop deployment. The concept of combined arms operations, in which air power supported ground forces, became increasingly important. These developments demonstrated that aviation was not just a technological novelty but an integral part of military strategy, capable of shaping the outcome of engagements in ways previously impossible. By the end of World War I, American military aviation had evolved dramatically. From the humble beginnings of Signal Corps Airplane No. 1, the United States had developed a fledgling but functional air arm capable of reconnaissance, observation, and limited combat operations. The experience gained during training, deployment, and coordination with Allied forces provided a foundation for post-war expansion, innovation, and doctrinal development. In the post-war years, many of the lessons from World War I informed the creation of the United States Army Air Service in 1926, the precursor to the modern U.S. Air Force. The emphasis on pilot training, maintenance infrastructure, tactical reconnaissance, and combined operations persisted, demonstrating the long-term impact of the early experiments and combat experiences. Aircraft design continued to evolve, with more powerful engines, advanced weaponry, and aerodynamic refinements, yet the principles established during the Signal Corps Airplane No. 1 era remain central. The story of early American military aviation illustrates a remarkable transformation. Within less than 2 decades, the United States progressed from observing fragile experimental aircraft to deploying a functional air service capable of supporting global military operations. The courage of early pilots, the ingenuity of engineers, and the foresight of military planners collectively forged a path that would eventually lead to American air superiority in the 20th century. In conclusion, the era from the acquisition of Signal Corps Airplane No. 1 to the end of World War I was defined by rapid experimentation, operational learning, and the emergence of aviation as a strategic tool. Early aircraft, though fragile and rudimentary, were instrumental in shaping military doctrine, training, and infrastructure. Pilots became national heroes, engineers pushed the limits of technology, and the military established protocols that would endure for decades. The foundation laid during these formative years ensured that American air power would continue to grow, ultimately culminating in the creation of the U.S. Air Force and the dominance of American aviation in modern warfare. Famous pilots and the rise of American air power. The emergence of military aviation in the United States was not only a story of machines and technology but also of individuals who transformed flight into a symbol of national pride and military capability. Early American pilots became pioneers, risk-takers, and public figures, demonstrating that skill and courage in the air could redefine the battlefield. These aviators laid the groundwork for the strategic development of U.S. air power throughout the 20th century. Among the first recognized heroes was Eddie Rickenbacker, a World War I ace whose career epitomized bravery, technical skill, and adaptability. Rickenbacker initially trained as a driver and mechanic, but his fascination with aviation led him to join the U.S. Army Air Service. Flying early biplanes that were often fragile and underpowered, he mastered the complexities of aerial navigation, gunnery, and combat maneuvers. Rickenbacker's 26 confirmed aerial victories earned him the Medal of Honor and made him a national symbol of courage. His success was not merely personal, it demonstrated the tactical potential of American trained pilots and inspired confidence in the rapidly evolving field of military aviation. Another influential figure was Billy Mitchell, a visionary who championed the strategic importance of air power long before it became widely accepted. Mitchell argued that aircraft were not just tools for reconnaissance but instruments capable of shaping the outcome of entire wars. He conducted experimental demonstrations, including the sinking of captured ships by aerial bombing, to prove that air forces could influence naval strategy. Though controversial at the time, Mitchell's advocacy directly influenced the establishment of the Air Service and later the independent U.S. Air Force, showing that vision and foresight could be as powerful as technical skill in shaping military doctrine. These pilots operated during a period of rapid technological change. Early aircraft were delicate and prone to failure, and flight conditions were unpredictable. Pilots had to master basic aerodynamics, understand engine mechanics, and navigate using rudimentary instruments. In combat, they faced the additional challenges of enemy fire, limited communication, and the physical toll of open cockpits at high altitudes. Despite these obstacles, their achievements demonstrated that trained aviators could conduct reconnaissance, direct artillery fire, and engage in aerial combat effectively, creating the foundation for modern air strategy. The accomplishments of early aviators also had profound cultural implications. Newspapers and magazines widely covered their exploits, portraying pilots as heroes who combined technical skill, daring, and patriotism. This public fascination helped secure political and financial support for aviation programs, ensuring continued investment in aircraft development, pilot training, and infrastructure. The stories of individual bravery contributed to a broader perception that aviation was essential to national defense, rather than a peripheral or experimental technology. In addition to combat heroes, early aviators also contributed to training and doctrine development. Experienced pilots documented flight procedures, maintenance routines, and tactical maneuvers, creating manuals that standardized operations. These guides informed the next generation of pilots, ensuring that lessons learned from trials, crashes, and successes were preserved. The systematic accumulation of knowledge transformed aviation from a hobbyist pursuit into a professional military discipline capable of supporting complex operations. During the interwar period, pilots also participated in aerial mapping, reconnaissance, and border patrols, demonstrating the practical applications of aviation beyond combat. These missions tested aircraft endurance, reliability, and versatility, providing critical data for future design improvements. Pilots learned to navigate long distances, deal with adverse weather, and maintain aircraft in the field, skills that would become invaluable in later conflicts. Each flight contributed to a growing understanding of how air power could extend the reach and effectiveness of the military. The period also saw the rise of air races, demonstrations, and competitions, which served both as public spectacles and as practical training grounds. Pilots tested speed, maneuverability, and endurance in highly controlled environments, pushing the limits of aircraft performance. These events spurred innovation in engine design, aerodynamics, and safety equipment. Pilots who excelled in competitions gained recognition, influencing public opinion and encouraging investment in aviation infrastructure and research. By the late 1920s and early 1930s, the cumulative impact of these pilots and their accomplishments became evident. The U.S. military had a growing cadre of trained aviators, standardized procedures, and increasingly sophisticated aircraft. The lessons learned from early pioneers influenced aircraft design, tactical doctrine, and strategic planning, laying the groundwork for the more advanced air operations that would dominate World War II. The courage, experimentation, and ingenuity of these early aviators directly shaped the trajectory of American air power. The story of famous pilots also intersects with technological evolution. Early biplanes gradually gave way to monoplanes, more powerful engines, and aircraft capable of carrying heavier payloads and flying longer distances. Pilots tested these innovations under real-world conditions, providing feedback that informed engineering improvements. This collaboration between aviators and designers accelerated the development of military aircraft, ensuring that operational needs and technological capabilities evolved hand in hand. In conclusion, the rise of American air power was inseparable from the individuals who mastered flight under challenging conditions. Pilots like Eddie Rickenbacker and visionaries like Billy Mitchell demonstrated that courage, skill, and strategic thinking could transform fragile machines into instruments of national power. Their accomplishments, both in combat and in the broader development of aviation, cemented the role of air power in American military strategy. The legacy of these pioneers endures not only in the aircraft they flew but in the doctrines, training programs, and institutional structures that continue to define the United States Air Force today. Technological innovations in early U.S. military aircraft. The evolution of military aviation in the United States during the early 20th century was driven not only by daring pilots but also by continuous technological innovation. Aircraft initially acquired by the U.S. Army, such as the Signal Corps Airplane No. 1, were rudimentary by modern standards, yet they sparked a period of experimentation and engineering that transformed military flight. From engine development to airframe design, early U.S. military aircraft underwent a series of adaptations that set the stage for modern air power. The first challenge engineers faced was power and propulsion. The Wright brothers' early planes relied on low-horsepower engines, often producing less than 12 horsepower. These engines limited payload, range, and altitude, constraining the operational capabilities of aircraft. As the Army expanded its aviation program, engineers experimented with more powerful internal combustion engines, incorporating innovations such as water cooling, improved fuel delivery, and higher compression ratios. By the mid-1910s, engines producing 50 to 100 horsepower became more common, enabling planes to carry observers, cameras, and light armaments while maintaining stability in flight. Another key area of innovation was structural design and materials. Early aircraft were constructed primarily from wood and fabric, leaving them vulnerable to stress and environmental conditions. Engineers began experimenting with steel tubing, lightweight aluminum alloys, and reinforced wing spars to improve strength without significantly increasing weight. These advancements allowed for larger wingspans, better lift, and more durable airframes capable of withstanding repeated takeoffs, landings, and even minor combat damage. aerodynamics emerged as a critical focus. Early planes relied on flat or slightly curved wings that generated limited lift and were prone to instability. Designers studied airflow, angle of attack, and wing camber to optimize lift-to-drag ratios. They also experimented with control surfaces such as rudders, elevators, and ailerons, gradually improving maneuverability. By adjusting wing shape, fuselage contours, and tail assembly, engineers created aircraft that were not only faster but also easier to control, enabling pilots to perform more precise reconnaissance and combat maneuvers. Landing and takeoff mechanisms were another major innovation area. Initial aircraft required long stretches of flat terrain for takeoff, with primitive skids or wheels that made landing hazardous. Designers introduced wheeled landing gear, shock absorption systems, and improved tail supports. These improvements increased operational flexibility, allowing planes to operate from shorter, less prepared fields and improving safety for pilots during repeated missions. Instrumentation and navigation technology also developed rapidly. Early planes often lacked basic flight instruments, leaving pilots to rely on visual cues, landmarks, and personal experience. Military engineers introduced altimeters, airspeed indicators, and compasses, providing pilots with essential information for altitude control, speed regulation, and directional navigation. Even simple instruments significantly enhanced operational effectiveness, particularly during reconnaissance or long-range missions where precise navigation could determine success or failure. Weaponization of aircraft began during this era as well. Initial military doctrine focused on observation and reconnaissance, but by World War I, aircraft were increasingly equipped with light machine guns, bomb racks, and signaling devices. Early attempts to mount guns led to challenges in synchronizing firing with propeller rotation, which engineers solved through the development of synchronization gears. These innovations allowed pilots to engage targets effectively without damaging their own aircraft, opening the door to aerial combat tactics that would dominate future conflicts. Communication technology also evolved in tandem with aircraft design. Observers carried basic signaling devices, while experimentation with wireless telegraphy allowed planes to transmit information directly to ground units. Although primitive by modern standards, these systems provided real-time battlefield intelligence, enabling artillery adjustments and coordinated troop movements. Communication advancements made early aircraft integral to command and control structures, transforming them from passive reconnaissance tools into active operational assets. Testing and iterative design played a central role in innovation. Each new aircraft model underwent extensive flight trials to identify weaknesses, refine performance, and ensure reliability. Pilots provided direct feedback to engineers, reporting engine behavior, structural stress points, and control responsiveness. This collaborative process between aviators and designers created a feedback loop that accelerated improvements, gradually producing more capable and resilient aircraft. Finally, the integration of modularity and adaptability became a defining feature of early U.S. military aircraft. Engineers designed airframes and systems to allow modifications, such as engine upgrades, weapon installation, or extended fuel tanks. This flexibility enabled the military to adapt to changing operational requirements, from reconnaissance missions to emerging combat scenarios, without waiting for entirely new aircraft designs. In conclusion, technological innovation in early U.S. military aircraft was a multifaceted process, encompassing engines, materials, aerodynamics, landing systems, instrumentation,